Welcome to episode 24 of CipherVibe's end-to-end cloud security architecture course. Regulatory compliance mapping connects legal, contractual, and assurance obligations to technical controls, operating procedures, owners, and evidence. It is most useful when it improves real risk management rather than producing one-time documentation. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Compliance consumes asset, data, identity, logging, encryption, vendor, and incident evidence from every architecture layer. It supplies governance priorities and audit-ready traceability back to teams that operate the controls. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is interpret requirements in context. Determine which systems, data, customers, geographies, and business activities are in scope before mapping a framework. Use qualified legal, privacy, compliance, and audit guidance for interpretation. Technical teams should implement approved requirements rather than inventing legal conclusions from a control title. The second building block is map outcomes to controls. Map each requirement or objective to implemented controls, owners, operation frequency, exceptions, and evidence. Avoid copying framework language into a spreadsheet without confirming how the cloud configuration, process, and records demonstrate the intended outcome. The third building block is collect durable evidence. Collect repeatable evidence such as policy exports, audit logs, access review results, change records, test outcomes, training attestations, and vendor assessments. Protect evidence integrity, record collection date and scope, and distinguish a point-in-time configuration from proof that a control operated consistently. The fourth building block is manage exceptions and changes. Govern exceptions with business owners, documented rationale, compensating controls, expiry, and review. Reassess mappings when services, regions, data uses, vendors, or framework versions change, and track remediation to verified closure instead of leaving audit findings as permanent known issues. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The reference compliance pattern defines scope, maps outcomes to operational controls, gathers durable evidence automatically where possible, and governs exceptions and changes through accountable review. Implement this layer in a sequence that preserves evidence and limits blast radius. First, confirm scope and obtain approved interpretation of obligations. Second, build a control-to-evidence map for priority requirements. Third, automate collection of configuration, logging, and review evidence. Fourth, assign owners and cadence for every control and exception. Fifth, test evidence retrieval and update mappings after material changes. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, treating certification or a benchmark score as proof of security. Second, applying a framework outside its actual scope without legal review. Third, collecting screenshots with no operating evidence or owner. Fourth, leaving exceptions indefinite after an audit closes. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, sample controls and retrieve evidence by scope and date. Second, measure evidence freshness, owner assignment, and exception expiry. Third, test a material architecture change against the mapping process. Fourth, review auditor and operational feedback for gaps in control design. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, create a compliance evidence map for a fictional payment service using encrypted storage, access reviews, logging, and vulnerability management. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that regulatory compliance mapping becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.